Hey everybody, how's it going? So in this video, like I said in class for my section 8, I said that I was going to do a video that went over problem 1. I'll go over problem 2 or 3, just one of those. Problem 4 I think is pretty straightforward, well, with the exception of D. I'll talk about this fprintf function a little bit. And I'll talk maybe a little bit about the input function, but I did ask Ben to talk about the fprintf function as well as the input function that you'll need to use for this problem 5 here. So what's really weird is I don't know if you can hear it. If you turn up the volume like really loud, like right now, okay, and then probably just like turn it down now. You might be able to hear like some music in the background. So if you look at the video, it's 12:21 right now, and it's pretty late. But someone like in another office is playing like really loud music. Well, they're playing like the Eagles, and I don't know what's going on. They're just like having a moment or something. But hopefully you can't hear it like too loud. But anyway, so here I have MATLAB open. I have the assignment open. And now I can just go ahead and get started. So like I said in class, I can set variables equal to just numbers or vectors or whatever, what have you. So for problem 1, for problem 1 and all the problems, I need to begin this way. So I need to begin by commenting my name, class, section, date, title, and goal for the code. So my name, and then we also need class and section. So either MO8 or either MO3 or MO8. You can probably just like skip this part of the video, I guess. And like, of course, you'll need your title and your goal. Okay. And then you'll need to like write some stuff here. I don't know. Whatever these two are. Okay, so I always begin my script files with CLC and clear because I want to, clear whatever is in this command window. I want to clear like this. I want to get rid of it. Then I also will want to clear whatever I've set previously. So I want to clear the command window, but also clear that x is equal to 5. Let me open this up. Make it a little bigger. Okay. Let's go to 12. Okay. So now I want to make sure that I set all of my variables equal to their corresponding values. So here I have the DJ Khaled is equal to 100. I have that Easy is equal to 5 million. X is equal to 15. Fetty is equal to, of course, not 39, 38. Data is equal to 50. And alpha is equal to 16. So now what I want to do is, you see like these little error things here, but this is because like it's asking me to like suppress each. Now I can't remember if I went over, I know I did with section MO3, but if you're in section MO8, I can't remember if we went over this. I think we did. So what this is going to do is it's just going to suppress this value, and it's whenever I run the code, it's not going to like redisplay it here. It's basically going to do this. So nothing's going to happen as soon as I say that x is equal to 5. But if I didn't do that, then MATLAB would again tell me. Now here what I'm going to do is I'm going to set my equation of jz is equal to yeezy. This is a lot like Excel. Plus 20 times theta. I'm going to put these in parentheses because I'm going to divide the entire thing by Fetty. And I'm going to suppress this for now. And the next equation that I have here is gamma. Gamma is equal to 3 times alpha divided by the square root of pi. And remember that MATLAB knows what pi is, that it's 3.14. So I can just put pi here. Plus DJ God. Okay, so now I'll suppress this. Now, E here says that I want to suppress variables Yeezy, DJ Khaled, JZ, and Gamma, so to not be redisplayed in the command window. So I want to basically, just for practice, which is why I have E there, I want to not suppress. I want you to know like what to suppress and what not to suppress. Okay, so in this case, this is what I will. So DJ Khaled, Yeezy, and JZ and Gamma. Everything else will need to be suppressed. Or wait, sorry. If I just like read the thing, it would make sense, right? So suppress Yeezy. We're suppressing DJ Khaled, JZ, and Gamma. Okay. So when I run this code, if you can't hear it, that's crazy because it's like really loud here. The music, I mean, I don't know, it's my desktop, I guess. I'll just call it P1. Oh, well, actually, you'll need to name it 1. And that's what you'll name it. And you'll name it you'll save it wherever you want to save it. I guess this is problem 1, so I'll save. If that comes up, click change folder. That way this folder can be like where you're taking the Flores_Charles1 file from. And this is what you should see. So if you did everything right, this is what you should see. And if you did everything even more right, then I should run your code, and when I call for JZ like this, you should get 8,631.19. So that's problem 1. Problem 2 is a little bit easier. Yeah, it's a little bit easier. It's not a lot of writing, I think. So what we'll do is we'll start with the same thing here. I guess I'll just put like problem 2. I kind of already know that this is problem 2 because if I go ahead and save as problem 2, this now changes to Flores_Charles2. I have CLC and clear. And now I will, let's see, go to A. So set X as a vector that goes from 0 to 100 real quick. So I don't know why I didn't put that as like Drake or something. I don't know. So X needs to go from 0 to 100, and it needs to go in increments from 0 to 100 real quick in increments of 0.5. So if I know my increments, then I need to use this operator, this colon operator, and my first number is my start, my second number is my increments, and my last number is my end. So this is officially going to give me a row vector that goes from 0 to 100 in increments of 0.5. If it went in increments of 50, then I should see, for example, 0 plus 50, and then plus another 50, which is 100. But here, it feels like 25. Oh. if it was like 25, you see how it would do like 0, 25, 50, 75, 100. But here what we're doing instead is, of course, 0.5. And so yeah, we have increments of like 95, 95.5, okay, like you, 96, 96.5, and so forth. And now I just want to perform the following equation. So you have that y is equal to sine of x over 50 plus cosine of x over 20, and that's it. So what I'm going to do is I'm going to suppress it, and now for every, so let's say if my x was like this, for every single x value that I have, this function is going to be performed. So 0 is going to be put into here and here. 25 is going to be put into here and here for this value, for the second value of y. 50 will be put into here and here for the third value of y. So if I did say that, I'll just like take this really quick. Well, I'll take this actually. So see, I end up with 5 different elements in y, because that's exactly what it's doing. It's taking this 0, putting it in here, and giving me some number. It's taking 25, putting it in here, and giving me some number for the second element of y. 50, and then putting it in here for the third element of y, and so forth. Now here's the more important part, which I didn't talk about for those of you in section MO8. So I need to plot x versus y. So the way that I'm going to do that is I'm going to use this function called plot, and it's pretty simple. You just, this is how you would write it. So you want to plot, this is where your excuse me, your independent variable will go in this slot of the comma, and or in this slot of the I don't know, command, I guess. And then in this slot, in the second slot after the comma, you will have your dependent variable. So if I plot this way and I hit run, a plot will eventually come up. There it is. Almost. Okay. So you see, like by default, it gives you a blue line, and yeah, we've sure enough have plot all these values of x versus y. Now I want to make some changes, so I want to give the line in the plot a red color with circles. So the way that I'm going to do that is, well, if you want to know like how to do that, then you'll type in help plot. You can type in like any function here, and it'll tell you about it. If you type in help CLC, it tells you, sure enough, that CLC clears the command window and homes the cursor, I guess. But we want to know a little bit more about plot. So with plot, we know that if I have a comma here, and whatever I put in here, if I set it up this way with an apostrophe, whatever I put in here, this is what's going to change how my plot is going to look. So if I want a red colored line, then what I'll need to do is put an R in this spot. So R, and then I want circles here. So for circles, I just need to put an O. And I'll close this up, and this is how I'll ask for my plot of x and y with red circles. So if I hit run, sure enough, there's like a bunch of little red circles there. Yeah. And this is problem 2. Problem 3 is the same thing pretty much, except that instead of the increments that you're given, you are given how many data points. So you won't use the colon operator, you'll use another function that we talked about in class. Now problem 4, so you have a bunch of variables and you have what they're equal to in terms of like their numeric values. And then you have this equation. So you know what k is, it's 0.6, you know what a is, 25. You know what th and tc are, 102 and 25, and then you know what L is, and it's 1.5. And then you want MATLAB to calculate what Q is. So that's pretty easy, right? You can just basically input these numbers into here. You can even do it with a calculator. You don't even need MATLAB. But I want you to put all these values, all these variables into MATLAB with their respective values. Put this equation in MATLAB. And the most important thing is I want you to display the value for Q up to 4 decimal places and then state its units in watts using the fprintf function. So let's go ahead and change this to problem 4. I don't need this anymore. And we can go ahead and save this as 4. So I don't know why I keep changing this. I guess just like for aesthetics or something. But now what we can do is go ahead and set all of our stuff. So I have K, A, TH, I'll just call like TH like that, TC, L, and then I need something for Q. So K is equal to 0.6, A is equal to 25, TH is equal to 102.2. Semicolon, 25, 1.5. And Q is equal to K times A times TH minus TC, right? Divided by L. All of that divided by L. If you're really good at math, then you know that you don't need these parentheses. You're going to get the same value. And then if you didn't know that, then know that you don't need these parentheses. As long as we're multiplying each of our different terms here, this isn't obviously multiplying or dividing, but we have these in parentheses. But if you're multiplying and or dividing just a number of different terms, you don't need, like, these parentheses are just like pretty unnecessary. If you want to have them for aesthetics, then by all means do it. I think that's a pretty good reason to have them. Okay, and then now I want to display, okay, so let me try to run this code to make sure it works. Okay, so it works. So now I want to display Q, the value for it, up to 4 decimal places, and state its units using the fprintf function. So in fprintf, I can use this tool, this function, to display information. So for example, if I wanted to say, I don't know if it'll work here. The duck swims on the lake. And I hit run. What's going to happen is MATLAB, after the code is ran, it's going to print whatever is in between these 2 apostrophes here. Notice here though that in my command window I'm prompted to start typing right after, and it would be better, I guess, if this were like one line down or something. To include my line, I'm going to add backslash and n, and I'll hit run. Okay. And the more I add, the more times it's going to basically hit enter. So see, now I have like 3 different spaces here, or well, 1, 2, and 3 different times. I would technically, I guess, just like press enter or return. But this is not what I want. So I want to say that something like the value of Q is, and then my number is going to go somewhere like right here. But this is where the fprintf function comes in handy, because we can call variables that exist earlier in the code. So the variable that I want to call is obviously Q, right? Because Q has a value that we want to display. So oh, it doesn't like the so the way that I'm going to do it is like this. So now this is another idea in MATLAB that we will use to basically call variables that we ask for here in the fprintf function. So we use a %, we use the number of decimal places that we want after that number, and then we use an f. So you might not know like why. Oh. You might not know why, but there's like a lot of different letters that you can use, but we use F because, like here, but we use F because we want to use this this like little function here. So what this is going to do, let's say I take all this stuff out and I just display what my number is, and I hit run. Now it's going to display my number up to 4 different decimal places here. If I change this to 2, what do you think is going to happen? Obviously, hopefully, we'd end up with just this, right? Where we have 2 decimal places. And that's exactly what we have. So if I have this up to 4 decimal places, and then I include my other information, the value for Q is, and then the number is going to be replaced for, the value for Q is going to be replaced here. And then I can just put a period to like end the sentence, I guess. And I hit run, and this is exactly what I end up with. But now I'm not entirely finished. I still need to include its units. So I need to state its units in, which is in watts. So here, I guess I can just write, instead of my period, I can write watts. And that's it. That's it for problem 4. Now, I'm going to let one of the, well, either Ben or Adam, depending on like who you have as a peer learning facilitator, talk about problem 5. Yeah, so that's it for this video.